All right, so we finished chapter 4, no rest for the weary. Moving on to chapter 5. Here we go. Actually, chapter 5 is a lot of review from Algebra 1, so it should be quick and easy, but don't tune out. Stick with me. We're going to use properties of exponents here, and you may be familiar with many of them because, as I said, I believe this is a review of Algebra 1. Sorry, I tell you what. And you know what? I'm just realizing that I might have made my... Hopefully you can see that in the video. Doggone it, I'll have to check and see. Oh, you kind of sort of almost can. All right, if you've got a number to a power times the same base to another power, you're simply going to add the powers. So 5 squared times 5 to the 4th simply means, this means 5 squared, so 5 times 5, and this means 5 to the 4th, so 1, 2, 3, 4. So that's why it's going to be 5 to the 1, 2, 3, 4, 5, 6. So we can just add them. Instead of writing them all out, we can just say, well, 2 plus 4 is 6, so 5 to the 6th, and then plug it into your calculator. You should end up with 15,625. Easy as that. If you were to actually take 5 times 5, you're going to get the same thing. All right? So using that property, you can take 4 to the 3rd times 4 to the negative 1 power, and you would just take 4 to the 3 minus 1, which is just 4 squared, which is 16. All right. So if you've got the same base and you've got powers on that same base, you can just add the powers. If you've got a base to a power and you're taking that to a power, then the property of power says that we're going to multiply those two powers, because this is the same as taking 5 to the 4th times 5 to the 4th. So then we're going to have 4 of them here times another 4 of them here, and that's where we get 4 times 2 is 8. So 5 to the 8th. And if you multiply that all the way out, you should get 390,625. So you would just take 5 to the 8th power in your calculator to get that. All right? So if you take a power to a power, you multiply the powers. If you're multiplying a base times different powers, then you add them. So don't get those two confused. If you have two numbers that you're multiplying and you're raising that to a power, you can either multiply first and raise the total to a power, or you can multiply each part separately and take each of those to the power. So you can either take 2 times 3 is 6 and take 6 to the 5th power, or you can take 2 to the 5th power times 3 to the 5th power. And whichever way you do that, you're going to end up with 7,776 as your total. So try it on your calculator and see. Take 2 times 3 is 6. Take 6 to the 5th. And see, you should get 7,726. And then take 2 to the 5th and get that answer. And then take 3 to the 5th and get that answer. And multiply those together, and you should also get 7,776. All right, so these 3 properties should be in your notes. All right, you should have those 3. If not, back up and get them. 4 more properties that you need to be able to use. The first one, and I'm just realizing I should have checked my height of my camera first. So anything to a negative power, that is it's going to flip it down to the denominator of a fraction. So you're actually dividing by it instead of multiplying it. So a 6 to the negative 2 power actually changes it to 1 over 6 squared, which is 1 over 36. All right. So if you have a negative power, and it actually works the opposite way too. If you've got a negative power in your denominator, that's going to flip it up to your numerator, and you'll see that as we do some examples. So make sure this is in your notes. A to the negative m power flips it down to the denominator. The next one, anything to the 0 power is just 1. So 32 to the 0 power is 1. 89 to the 0 power is 1. 563 to the 0 power is 1. Negative 3,689 to the 0 power is 1. Anything to the 0 power is just 1. All right? Easy sneezy. A to the m power divided by a to the n power is going to be a to the m minus n. The reason for that is simply that we've got the same base. We can cancel any that match, and so we're going to take whatever power we have in the top and we're going to subtract off that n. So, and it works with negatives also. So if you have 6 to the negative 3rd over 6 to the negative 6, that's going to end up being 6 to the negative third minus a negative 6. So if you're going to add that 6, so you've got now 6 to the third power. So now you've got, oh, why do I have that as that? So 216 should be your final answer if you take 6 to the third power. Because this negative 6 was in the denominator, when we flipped it up to the numerator, it made it positive. So now, what's actually happening is we're canceling out. We've got negative 3 here, so negative 3 here cancels out, and so that's why we've got now it's in the numerator, because we've got negative 6 over, it's 1 over 6 to the negative third, so that bumps it up to the numerator. All right, we'll do some more examples of those to see, because that negative exponent flips it to the other side of your fraction. All right, if you've got a divided by b and you're going to take it to the m power, then you can either, once again, you can either divide them first and then take it to the power, or you can take each part to your power. So a to the m power over b to your m power, and then take your powers first and then divide. So in this case, if you've got 4/7, 4 divided by 7 is not going to be pretty. So let's just take 4 squared is 16, and 7 squared is 49, and just be done at that point. All right, so all of these in black should be in your notes now. Those are the properties that we're going to use. Let's use them now. Let's do them. So the first thing we're going to do with these properties is we're going to actually evaluate, and we're going to find out, well, how much do these things equal? And what I want you to do is, I know you can just do it all in your head. I want to see the steps, because I want to see which direction you did it. I want you to use the properties to show what you've done. So I want you to show me, this is negative 3 squared to the third power times 5 to the third power. All right, so when you multiply it out, so you've got 9. Negative 3 squared is 9. Negative 9 to the third power times 5 to the third, because this 3, the squared is only on the 3, not on the whole negative 3, so that stays negative. So negative 9 to the third power, and I'm going to do what I've already done here. Except that, guess what? Let's multiply them. Duh. Here we go. So instead of actually working it out, let's use our property like I just said to do. So 2 times 3 is 6, so you've got negative 3 to the 6th power times 5 to the third. And so negative 3 to the 6 is going to be negative 729 times 125, which should get you negative 91,125. All right, so actually use those properties. Sorry, I should have looked at my notes first, huh? So 2 times 3 gives you the 6, and you split them apart, and then you can work it from there. All right, in here, we're going to divide and then bring to the powers. And so instead of dividing first because of ew, yuck, we're going to multiply those powers first, because we're taking a power to a power. So we've got 1 to the 4th to the negative squared. So we've got 1 to the negative 8 over 3 squared to the negative 2 is going to be 3 to the negative 4. All right. Now, because they're negative exponents, we're going to flip that fraction, or we're going to flip the parts of the fraction that are negative, and they happen to both be negative. So this negative 8 power is going to flip this 1 to the denominator. So 1 to the 8th power is going to be in the denominator. And this 3 to the negative 4 is going to flip up to the numerator, because the negative exponent flips it to the other part of the fraction. So you're going to have 3 to the 4th in the numerator. So 3 to the 4th is 81, and 1 to the 8th is just 1. So your final answer is 81. And I didn't give myself enough space. Phew, rough today. All right. Okay, so evaluating, really, you shouldn't have any trouble with that. Just make sure that you're using properly. You got to go slowly. Make sure that you're using those properties properly. So make sure that if you've got a power to a power, you multiply it. And make sure that if you've got a negative power, it flips to the other part of the fraction, because you're dividing instead of multiplying. All right? All right, next. Scientific notation. The reason we're talking about scientific notation in this area is because scientific notation uses those exponents quite a bit. So scientific notation is, and this is not, you can use their definition has a little bit more, I believe it's on the top of page 331 has the book's definition. I like to just put it in my own words. It makes more sense to me. If it doesn't make more sense to you, go to the book, go to that definition, and you rewrite it into your notes, into words that make more sense to you. Alrighty? So what makes sense to me is a scientific notation is if there's one number to the left of the decimal times 10 to the power it takes to move it back to the actual number. So in this case, 8.5 has one number to the left of the decimal times 10 to a power that it takes to move it back to the actual. So if you were to move this decimal 7 places to the right, you're going to get to the actual number that this is. All right. So, and that also you should have done before. So I'm not going to camp out there. If you don't remember scientific notation, check it out in your book. Look at this definition. Ask me. All right. Here we go. Because what we're mostly doing is we want to use our properties of exponents here. We can also use our properties of multiplication to say, well, this is all 4 of these numbers are just multiplied together. So we can use our commutative property to move these whole numbers, or not whole numbers, these numbers without exponents together and say 8.5 times 1.2, and then move these powers of 10 together and say 10 to the 7th times 10 to the 3rd. And when I multiply this, like I already did, you should get 10.2. 10.2 times 10, because 10, what we've got is 10 as a base, 10 to the 7th power times 10 to the 3rd power. Remember, if we're multiplying numbers with the same base, we're going to keep the base and we're going to add these exponents. So 7 plus 3 is 10. So we've got 10 to the 10th power because we've got 7 of them here and 3 of them here, so we just added them together. Now the only trick is this isn't actually scientific notation because we've got 2 numbers to the left of the decimal. So what we're going to do is we're going to move this and say, well, I want to move it. I want to say this is 1.02. And you can do that as long as you say, well, this is 1.02. I moved the decimal over, so I'm going to take that times 10 to the 1 power because it'll move it back to where it was here. But I also have this 10 to the 10 power that I didn't change. So this 1.02 times 10 to the 1 power is the same as this, and this is the same as this. So we haven't changed the value of our number at all. So now, because we've got 2 base 10s here, 10 to the 1 power and 10 to the 10 power, I can simply add these exponents. So my final answer in scientific notation would be 1.02 times 10 to the 11th power. All right. So there are lots of others lots of other problems in scientific notation. If you're not sure, go ahead and do a couple more of those and verify and clarify. What we're going to move to now is just simplifying within. We're going to actually move into algebra instead of just mathematical processes. We're going to use algebraic processes. Let's simplify some of these more complex expressions. I'm going to show you several, and if you think you've got a handle on it, pause it and do them and then come back. All right? So this is 1, 2, 3, 4 different examples that I want you to work out and then come back. So pause it and work them, and if you get stuck, then come on back. All right? Here we go. And hopefully you did them already. You know I always do that. Here we go. The first one is going to be w to the 5th times w to the negative 8 times w to the 6th. They're all the same base. So because they're the same base, we're going to add their exponents. So this is w to the 5 minus 8 plus 6. So now we just can combine them. So we've got 11 minus 8 is w to the 3rd. 8, 9, 10, 11. Yes, making sure. All right. So moving on. I hope that's what you got. Here we go. The next one, c over d to the negative fourth, all raised to the negative 2. Remember, what we're going to do first is we're going to get rid of these parentheses. So each part is going to get this exponent. So that is the same as c to the negative 2 over d to the negative 4 raised to the negative 2 power. All right, so this negative 2 power is on each part separately. So now the c to the negative 2 flips down. So we end up here with 1 over d to the negative fourth negative 2 times c squared. All right, so that simplifies the c to the negative 2, bringing it down. Now we need to simplify this part, and you can do these in the same step once you see them all. I'm doing them one step at a time so you can see each step separately. So now d to the negative 4 times negative 2 is going to be, we're going to move it down here where we can see it, 1 over negative 4 times negative 2 is a positive 8. So we're going to have d to the 8th c squared. And you can leave it like that, or you can put it in alphabetical order. So 1 over c squared d to the 8th is your final answer. All right. Next one, a to the negative third b squared over a to the 5th. All right, so what you can do here is you can either move this a up and subtract them, because because if you're one on top of the other, you're going to subtract them. What I would actually do, because this is a negative 3 on top, I would move that a to the negative third down and combine them that way. All right, so the b squared is just going to stay there. It's simplified. There's no other b's here, and it's simplified. It's done. But this a to the negative third can be brought down. So b squared stays on top. And the a to the negative third, when you bring it down, now it becomes positive. So you have a to the 5, and it becomes positive, plus 3. So you have b squared over a to the 8th. And that is your final answer there. All right, so were these easy? Are you getting them? I'm going to make sure. See, I've made enough mistakes that now I always check my answers and make sure, because I do them ahead of time. All right, last one. Here we go. A squared b to the negative 1 over 2a cubed b squared all to the third. So the first thing you want to do is you want to get rid of the big parentheses. So you want to take everything to the third power. So everything needs to get that power. So you're going to take a to the 2 times 3 is 6. B to the negative 1 times 3 is negative 3 over. Now remember, everything on the bottom gets the power, including your whole number. So 2 to the third power, not 2 times 3. 2 to the third power is 8. A to the third power raised to the third power is going to be a to the 3 times 3, which is a to the 9th. And b squared to the third power is going to be b to the 6th power, because you take the 2 times 3. Now we can simplify. So what we're going to do here is we've got a to the 6th and a to the 9th. You can either move this up and do the subtraction, or what I do is I realize, well, 9 is bigger, so it's going to end up being in the denominator. It's going to end up being down here. So I would take the a to the 9 minus 6. So I've got to have, so I look at each part. So the a is now going to go to my denominator because I've got 6 on top and 9 on bottom. So in essence, another way to think of that is that 6 of these are going to cancel, and 6 of these are going to cancel, and what's left is 3 of them. And that's the same as thinking, oh, if we bring it down here, we've got 9 minus 6. So we've got a to the third power on the bottom in your denominator, and we've got b to the 6th in your denominator, and we've got b to the negative third in your numerator. So the negative third is going to bring it to the denominator, and when it comes to the denominator, now it's going to be positive. So you've got, so when you bring it down here, it becomes positive. So now it's 6 plus 3. So you've got b to the 9th. And now because we brought this down, there's nothing left on top. And you know that if there's nothing there, what actually happened is we reduced it to 1. We didn't subtract it, we divided it. So we reduced it to just 1, and this 8 is still in the denominator. So this is your final answer for that problem. All right, one more that's going to go quick. Here we go, because you know I can't stop without doing a word problem. The radius of Jupiter is about 11 times greater than the radius of Earth. So how many times as great is Jupiter's volume? All right, so we know the comparison of their radii, and we want to compare their volumes. So we need to know what is the volume of a sphere. So the volume of a sphere is 4/3 pi r cubed. And hopefully you just knew that. If not, you're going to have to go back and find your formulas. So if you want to know how many times as great is Jupiter than Earth, you're going to put Jupiter's volume on top divided by Earth's volume. So Jupiter's volume is 4/3 pi times its radius cubed. And we said that Jupiter is 11 times greater. The radius is 11 times greater. So let's call Earth's radius r. So now Jupiter's volume is going to be 11r cubed. And Earth's is 4/3 pi r cubed. All right, so Earth's volume is 4/3 pi r cubed. Jupiter's volume is 4/3 pi times its radius cubed. Its radius is 11 times the radius of Earth. So now what we have is, we can simply reduce some things here. 4/3 can reduce because there's one on top and one on bottom. Pi can reduce because it's on top and bottom. In this case, we've got 11 cubed and r cubed over r cubed because this cubed, remember, is on both parts. So now your r cubes can cancel out also. So your final answer is 11 cubed, which I figured out with my handy dandy little calculator, and it's 1,331 times. So that big scary looking problem can be reduced down when you know your properties of exponents. Enjoy. See you soon.